What's going on? Zach here with 5-Star Prep, and today we're going over two SAT math questions. One that really highlights how tricky this exam can be, and another that, when you look at it, you may go, what the hell do I need to do here? Let's go ahead and work them out. Here we have question 9 from the SAT, and it gives us the equation the square root of x minus a equals x minus 4, and says if a equals 2, what is the solution set of the equation above? I'm going to go ahead and rewrite the equation, plugging in 2 for a, and that leaves us with x minus 2 equals x minus 4. And now I can go ahead and solve for x. The first thing I want to do is square both sides, and that leaves me with x minus 2 on the left equals x minus 4 times x minus 4. And now the right hand side can be FOILed, and that gives me x squared minus 8x plus 16, and that should equal x minus 2. Well, in order to solve a quadratic, the left hand side should equal 0, so I'm actually going to subtract x and add 2 to both sides, leaving me with 0 equals x squared minus 9x plus 18. And now x squared minus 9x plus 18 can be factored, and it factors into x minus 6 times x minus 3. And that should equal 0, and now we can solve for x. Solving for x leaves me with x equals 3 or 6. But it's so important to check if these are both solutions, because 3 ends up being an extraneous solution here. So A is not the correct answer. Instead, D is. But in order to avoid this, we can just plug in our solutions. So I'm going to go ahead and erase all this work we just did and actually approach this problem in a different way. All I want to do is actually plug in 2, 3, and 6 because those are the possible solutions in my answer choices, and see which ones work. So going ahead and plugging in 2, we have the square root of 2 minus 2 equals 2 minus 4. And looking at the left-hand side, 2 minus 2 is 0. The square root of 0 is 0. Does that equal negative 2? No, so 2 is not a solution here. How about 3? Plugging in 3, we have the square root of 3 minus 2 equals 3 minus 4. And the left-hand side, 3 minus 2 is 1. The square root of 1 is just 1. Does that equal negative 1? No, so 3 doesn't work either. Let's plug in 6 now. 6 is the square root of 6 minus 2 equals 6 minus 4. The left-hand side, 6 minus 2 is 4. The square root of 4 is 2. Does that equal 6 minus 4, which is 2? Yes, so 6 is a solution. It's actually the only solution, and that's why the answer here is D. Taking a look at question 14 now, it gives us the expression 8 minus I over 3 minus 2i, and says if the expression above is rewritten in the form a plus bi, where a and b are real numbers, what is the value of a? Note I equals the square root of negative 1. Well, from the note here, all we need to know is that I squared equals negative 1. And that's so important whenever we see a complex numbers problem. But how the hell are we going to get this expression up here in the form a plus bi? Let's go ahead and figure that out. We have the expression 8 minus I over 3 minus 2i. And whenever I see an expression like this, usually you want to multiply by the conjugate. So I want to multiply by 3 plus 2i in the numerator and 3 plus 2i in the denominator. Notice 3 plus 2i over 3 plus 2i can simplify to 1. So we're just rewriting this expression. We're not really changing it in any way. So multiplying out the numerator, that gives me 24 plus 16i minus 3i minus 2i squared. And then multiplying the denominator leaves me with 9 plus 6i minus 6i minus 4i squared. And I see here that I actually have some like terms. 16i and negative 3i in the numerator, and 6i and negative 6i in the denominator. 16i and negative 3i is going to combine to give me 13i. So I can rewrite the expression as 24 plus 13i minus 2i squared over 6i and negative 6i actually just cancel. So the denominator becomes 9 minus 4i squared. And now remember that I squared equals negative 1. So instead of having negative 1 in my expression, I want to go ahead and replace that, or I squared in my expression, I want to replace it with negative 1. let's go ahead and do that. And that leaves me with 24 plus 13i plus 2. And in the denominator, 9 plus 4. And now I see I have 24 and 2 in the numerator. That combines to get 26 plus 13i in the numerator. And the denominator, 9 plus 4, is just 13. So my expression ends up becoming pretty simple, 26 plus 13i over 13. But we can simplify that once more. And simplifying it gives me 2 plus I. And that is my final simplified expression. And taking a look at the question here, we want it to be in the form a plus bi. And they're asking us for the value of a. The value of a is just my number all by itself, which is 2. So my answer here ends up being a or 2. I know it can look complicated to begin with, but if we take the necessary steps, we can actually break it down, and it just ends up being a lot of multiplication, simplifying, and combining our like terms, and we end up finding out that the answer here is simply a or 2. I hope that helped. Don't forget to like and subscribe. Also check out 5starprep.com for more videos. I'll see you next time.